Thank you so much, Victor, for joining us today. I'm so happy that we can have this conversation. I've been following you already for a long time on your LinkedIn page and reading everything you're writing about design of experiments and how you use it in your daily job. You're like a chemical engineer from origin, and I would really love to hear about your fascinating career in research, and wanted to know if you could tell us a little bit about your journey and how you got into this field and how that you became an expert in design of experiments.
Yeah, sure. Thanks a lot for the invitation first. The story behind design of experiment is a bit of an hazard for me because as you mentioned, I'm a chemical engineer by training, and I've always been fascinated by chemistry and all the application that chemistry can have, like on energy, transportation, pharmaceuticals, cosmetics, and so on and so on. Many life goods couldn't be made without using chemistry. And I think DoE came at the right moment and at the right place in this learning when I was doing my engineering studies, because I wanted to dive deeper into the formulation part of chemistry. And in formulation, the basic principle is, in fact, to mix a lot of different compounds, but without creating chemical reactions. So you have to know what are the compounds that are stable together and which one do provide a synergy in terms of performances or response that you can measure. And in most of the situation, it can be quite tricky because you will mix a lot of different compounds, and without a very strategic approach, it's very hard to distinguish and differentiate which compound or which raw material do have an effect on the response you are measuring. So when I was doing my formulation courses, we had a passionate teacher who introduced us to design of experiments. And very quickly, I completely fall in love with DoE because it really resonates with me about this strategic approach to know which factor do influence my response or my responses. And it really provides a strategic framework on how to do experiments and how to learn from them without wasting resources, times, materials, and so on.
Yeah, actually, it was going to be my second question, like when did you came across design of experiments and what made you interested in it? But maybe then going on is like, what was then your first design of experiments? Like, when did you like do it for real, like not like in an academic context, but really saw like, okay, here I can really apply it, and that you had like your real first success?
Yes, outside of my engineering studies, I proposed the DoE in my first job for several topics. And the first design I was able to create on this specific topic were very instructive because, as you mentioned, it's the first time I was able to do DoE on a very, let's say, industrial scale, or at least with an industrial setting. Still in R&D, but with a strong link to industry and to customer application. And it was very rewarding to see that it's not only working great in courses and in academic context, but also with also in an industrial context with possibly different raw materials, with different batches, also different way to evaluate your product. And in fact, I think it's even more instructive to do DoE on the industrial side than on the academic side when you look at how to do what to measure first and how to do your measurements. Because in an academic context, you have a problem, and you know in advance on which factors you will have to study and which responses you have to collect in order to answer the question and the problem statement. In industrial context, you have a lot of opportunities and a lot of choice possible. So you have to really engage with domain experts, filter out what are the possible options to do on the response and on the factors sides. And at the end, try to converge on a design that satisfies your criteria and that satisfies also the needs from the business.
You mentioned that you indeed were able to use it in your first job, and did you have any trouble with convincing them for using design of experiments? Because maybe like for people who are not familiar with design of experiments, maybe can you shortly explain in your words? Of course, I know, and we're doing it on a daily basis, but it's always interesting to hear it again from an expert. And then, yeah, how did you convince peers and managers to actually use it? Because we do see still a lot of adoption barriers in using design of experiments.
Yes, I think, as you mentioned, there are a lot of barriers on adopting design of experiments, and they may not be related to, let's say, scientific aspects or, technical aspects, but more on the change and user adoption sides. The first thing that I saw when using for the first time design of experiments in my previous job was that people tend to confuse design of experiment with domain expertise, meaning they see a kind of conflict between the two because they think that you do not leverage domain expertise when you are designing a design of experiments. They can say, oh yes, you are trying to investigate this interaction, but we know already that it's working great. Or yes, in your design, you have a point that is in this experimental area, and we know for sure that you won't be able to have reliable results or stable formulations in this experimental space. And this is, I think, the hardest part is to be able to align domain experts with the DoE methodology because they can see it first as a waste of resources or a waste of time. But really the key part is adoption of the domain expert and integration of domain expert in the design creation, meaning taking into account their inputs for the factors to investigate, maybe the range also to investigate, the design space to create. Sometimes also you have to take a step back and not go into full details with domain expert, because sometimes you also need a new, fresh view on your domain, on your domain, experimental domain. Domain experts sometimes may already have done some experiments in a specific area and something like that, that show that the results are not good. But still, design of experiment is not a methodology about doing only experiment that works. If you want to learn something from design of experiments, you need to have both good results and bad results. So you need to have this kind of variability in the response, accept to have bad results as well as good results.
I think that's the main key, that indeed, that for design of experiments, the idea is that what you make in those experiments is not per se something that has to be good, and that it's actually that you make you fail actually to learn from the failure. And I find that a very interesting concept, because people always talk about, if you talk about experimentation, they kind of assume that you will immediately make the good product, whilst it's just actually the other way around. You try to learn as much as you can from from actually operating conditions that are not normal in order to learn from them. Yeah, I think that's the cool part about design of experiments. Now, you work today at L'Oréal, and it's known for innovation. And I just wanted to know, like, how does design of experiments fit in your role and in your daily work? Yeah, can you describe how it is used or in the operation?
Yes, DoE is deeply rooted into the experimental strategies of L'Oréal laboratories. So it's a big chance for me to be able to participate in this environment and working with the different domain experts in the labs. I'm also very grateful about being here because DoE are used a lot, and there are a lot of variety in the topics that we can deal with DoE. We can create DoE very early in the process, meaning we want to investigate new raw materials and create simplex mixtures that shows good performances. We can also create DoE in the development phase, meaning we already have a list of ingredients, and our goal is to optimize the formulation in order to reach specific performances with good stability, good price, and a lot of different indicators. And also, DoE can be used also at the end when you are doing a pilot scale and when you are pushing, let's say, the product to production, because production accidents may happen, and you need to really quickly investigate what's going on wrong, or what is or are the key factors that could explain what is going wrong into production. And so you also need at this stage DOE in order to investigate the scale up situation in production, but also you can also do DOE in order to assess and, let's say, verify the robustness of your product with regard to very little change in production, and make sure that the product stay with the same performances no matter where it is produced.
Can you then say that design of experiments change the way research is conducted within the cosmetics industry? Does it really make an amplification on innovation?
Yeah, I think we are really closely related, let's say, sometimes to the pharmaceutical area, because a lot of techniques and methodology are also applied in cosmetics. For example, quality by design is also something that we are pushing forward in the cosmetics. So
I think maybe an additional question that makes it more tangible maybe is that, if you look at the design of experiments that you have done already today, what was then the one that you said there it played a really crucial role? If you wouldn't have done design of experiments, then what you would have tried to reach would not have happened.
Okay, yeah. I think there are several topics where really DOE made a great impact, because, as we mentioned earlier, it's all about exploration and learning, and not only optimization. Optimization can sure be done with DOE, but the aim is really to learn what is providing good results and what is providing bad results. And we have several topics like this, where we used design of experiments not only to optimize product performance, but also to learn more about interaction between different raw materials, in order to leverage some knowledge for the labs, in order to provide new knowledge for them, and to understand why some performances can be achieved by the combination of different raw materials.
And if you say performance, I have to think about how things are textures and how something smears or something. Is that how I have to look at it?
Yes, we use a lot of different type of responses. So we have instrumental measurements in order to check for physical characteristic of the product, but we also have some sensorial measurements. And on this part, we really want to be sure that the product meets the consumer expectation. And in order to do this, we have to really explore what is possible in terms of experimental space with DOE, in order to make sure that we have not restricted our search to a very narrow area, and that we are sure that the learning we have gathered on this experimental space is robust.
And maybe then following up, because design of experiments is already here for a long time. So what would you say is the most excited innovation or evolution that you have seen in the field of design of experiments itself?
Yes, there are some really major milestones in design of experiments. For sure, it's a very long story. If we look back at the early beginnings of DOE in the 1950 or something like that, with the works from Fisher, for example. I think one of the major breakthrough was really the way to create design of experiment with computer, with the rise of optimal design in the years 70. And I think since then, it's really great, because we see that the two way to create DOE, so based on very specific metrics and based on computer calculation, are very complementary. And it's really great to see today that there are some major advances in these two approaches. So we had major advances on let's say classical statistical design with definitive screening design, OMARS design, OML designs, and so on. But also on the optimal and computed design side, there are also some great research topics dealing about new optimality criteria, in order to lower the risk of not taking into account an effect or a factor very early in the design creations. I think it's very good to see these two approaches receiving so much research and so much attention. And I really would like that this area of research would be more widespread, let's say.
Maybe like jumping ahead a little bit, but do you see also, I assume like at L'Oréal, there's also like investigation on how artificial intelligence probably can help you on digital twins, but maybe on a more general level, like how do you see that evolution, like the marriage between AI, digital twins, and design of experiments? Do you see the advantage of still using design of experiments, or would you say like, okay, because of AI, it will like be dead in a year or something?
Okay. No, I think it still has a big and very important place, because at the end, when we talk about AI, it's machine learning or statistical learning or any method that could analyze your data. And the model are only good if your data is good. So in some cases, you have a sufficient, let's say, a sufficient coverage of your experimental space to perhaps not use DoE in the first place, but leverage your historical data and do some analysis on it. But if you are looking to improve your model or do some remediation, or if you have a very large data set that is, let's say, not possible to analyze directly, maybe leveraging the design of experiments approach could help you select a subset of this big data set to only analyze a representative subset that could help you find some answers to your questions. So I really think AI has a lot of opportunities, but also DoE, and the combination of the two could really help providing better model and more reliable models in terms of adoption, because for example, the new large language model or similar models could really help lower the adoption barrier of DoE to new people in this domain by explaining the different concepts and taking a step-by-step approach on which steps to realize before creating your design, and also on the more technical and analytic parts. I think leverages new models like we can today from machine learning, from deep learning approaches could also really help improve model precision and the predictive performance of such models.
That's really interesting, and indeed in the part where you say that it can be used also to help explain, it's also something that we're investigating at this point actually with FX, to see like how can we translate industry specific topics to the generalistic language of statistics. So, but that said, do you think that like companies in general like recognize the full value of design of experiments, or is there still some convincing to do? How important do you think that it is that there's like a company culture where design of experiments is like embraced and like really systematically like
To answer very directly to your question, I don't think DoE is enough present in the different industries today. The adoption is still limited, and I think most of the problem lies to, as you mentioned, the statistical language and all the knowledge you need to have in order to create your design of experiments. But still, I think you can start very easily with some very simple design, like classical design, screening design, response surface model design that are available since almost a century now. So I think the user adoption can still be improved on this part by showing very simple example and showing that you don't need to be a statistician to realize your own DoE. You just need some, let's say, rigor, a domain expertise, and a clear view about your objectives and your outcomes, your expected outcomes. But yeah, no, it's not enough widespread for sure. And really, it should be more widespread. As you mentioned, it's also a question of company culture, because when you do a DoE, you need to accept the risk of having bad results. You need to accept the risk of failure, in fact. And not all companies are willing to take this risk. But by not taking this risk, you are limiting the knowledge and the learning you can gather from your experiments. So it's a compromise to choose.
Well, it's kind of funny because it kind of leads me directly to my next question, which is like, what are like common misconceptions that people have about design of experiments? And also, yeah, what makes them hesitate to invest in design of experiments? Because, yeah, as you say, you have to be prepared to fail, but failure has a cost. And so why you also find that a very short-sighted decision, and how is that, yeah, within your job, how do you look at it? So first, like maybe the misconceptions, and then why there is like this hesitation to invest in it.
So one of the misconceptions we already have discussed is the fact that people expect from DoE to have already the perfect solution to their question, when in fact you may not have the perfect solution directly in your experiments, but you can probably deduce it from the model you have generated thanks to the experiments you have done. You need to accept the risk to have some failure in your experiments, but this is part of the learning. But yeah, not all people are willing to take this risk. So yeah, I think this is the most common misconception. And what was the second part of the question? Sorry.
Well, yeah, the thing is that with that misconception, of course, there's also the question of cost. And some companies like really hesitate to invest in design of experiments because they see the cost upfront. And yeah, I just wanted to know, like, how do you cope with that also within your job? Because I assume you will also have to kind of calculate what is the cost of an experiment, but then what is can you explain why it's a short-sighted decision to not take that cost up front, and what happens when you do not do design of experiments?
Yeah, the big advantage of design of experiment is that you know upfront what would be the required number of experiments you have to run in order to gain a specific learning on a specific experimental space. And not all methodology enable to have this kind of planning knowledge about the experiments you need to do. So I think this is one of the biggest advantage of design of experiments, this planning and logistic part, because you know in advance how much raw material will be needed, how much equipment, how many equipments need to be used for running the analysis of your design of experiment. And you can calculate in advance the costs linked to this design of experiment. If you are doing one factor at a time, or let's say other type of optimization approach, you don't always know in advance the number of experiments you will be required to do in order to optimize or gather some learnings about it. So you may have, in fact, higher costs with those types of methods, because at first you will only need to do like 3 experiments, and then 4, and then 2, and then 1, and so on. But the number of iterations, the total number of experiments could be higher than what you can do with one design covering your experimental space and with all the knowledge you need to gather to specify a certain model. So yeah.
We all know that some people also have like real bad experiences with design of experiments. So what could you think are the like most common pitfalls, and how can they be avoided?
I think the key part is to start small, maybe on a topic that is not completely unknown, that you are familiar with, in order to be able to validate the learning from the design of experiments. So you should not choose a complex system with dozens and dozens of factors to investigate. Maybe a more simple one with like 3 to 5 factors to investigate. And if you already have some prior data or prior knowledge about it, it would be best, because you can learn new things from these systems, but also validate some of the learnings you already have done on it. And this also enables to align domain experts with the people doing the design by showing, okay, we can validate and we can model what were your learnings, but we can also find new things to investigate further if needed.
I think that kind of like links to another question, is that collaboration is always key in research. And how do you think then design of experiments helps also bridge the gap between different teams and experts? And how do you see that in your job as well today?
Yeah, today we have a big collaboration between the people doing the DoE and the domain experts. Some of the people in the lab can already do their own DoE in autonomy, but for some complex cases, we can be involved in order to do a specific custom design that really match the constraint and the requirements. But I think the key is to be able to speak the same language, meaning it doesn't make sense to speak, let's say, statistics to a chemist. So we have to be on the same table. We have to speak the same language. So that's why I think having a chemical background in this situation is very helpful for me, because we can really dive deeper into the raw materials, the different conditions they want to investigate, the different synergy between raw materials and so on, and the different type of responses as well. But the key is really to be able to align on the same vocabulary and at each step to be sure that there is no misconception or misunderstanding, and to validate each step during the design creation, meaning being able to validate what will be the key factor to investigate, the ranges, any constraints, if you have some, the assumed model, or let's say the knowledge you want to gather from this design, meaning do you want to only filter out the main active effect, or do you want to dive deeper and do some optimization? To balance all of this with the experimental budget that the lab can allow for this design of experiment. Because it doesn't make sense to recommend a 120 runs design when the lab can only do 30 runs for this project. So you have to balance the level of expectation and the knowledge the lab wants to gather with the practical feasibility of the design in terms of runs and experimental budget.
So you said you were a chemist, but you also are a design of experiments expert. And so I just was wondering, like, do you think that design of experiments is sufficiently taught in universities, or is there still like a big knowledge gap between young professionals and the industry?
I don't have a clear view about how or if DoE is taught at different universities. I still think that most universities in the chemical area do teach design of experiments, so that's a great point. But obviously, when you look at what's going on in industry, DoE is not enough used and understood by people. So I think we still need some efforts in democratizing design of experiments and show what is the added value of doing design of experiments compared to not having a strategy at all when running experiments in the lab.
Maybe a follow-up question is then, some might indeed hesitate to use design of experiments because of the fact that they think it's too complex. And you already said, like, you can start with smaller experiments, but what would you consider like the minimum knowledge somebody would need to actually start with design of experiments?
The good thing about design of experiment is that it's very practical, and it can also be very visual, meaning the early design done in 1940 or even before were not really analyzed with a sophisticated analysis and computer. Really were analyzed doing a graph and showing what is the mean value when your factor is at level A versus what is the mean response value when your factor is at level B, for example. So I think you don't need a big statistical background to start with DoE. You just need to have a clear view about what you can expect from design of experiments and adapt the design to your expectation. Meaning, if your primary goal is to identify the active effect in your system, then just start small with a screening design, and you don't need a very sophisticated screening design to start doing design of experiments. Plaquette-Burman or classical screening design can really help in identifying main effects, and the analysis can also be quite straightforward for this. So it's linear regression with only main effects. So you don't need a lot of statistical knowledge to start using DoE.
And like, what would you consider like being like the biggest competitors of design of experiments? Like, would you consider like other methodologies or just simply doing nothing?
I don't think there is a competitor to DoE in the sense that different methodology may have different objectives. For example, there is a lot of discussion. There are a lot of discussion and talks about Bayesian optimization for chemistry. It's also not a new method because it started in 1970, for example. But now it's growing a lot in the chemical community. But I don't think DoE can be replaced by Bayesian optimization or the other way around because they have different objectives. One is about DoE is about learning, identifying important effects and optimizing, whereas Bayesian optimization is only, like the name suggests, only about optimization. So that means, okay, you can reach a hit, you can reach a product that match your requirements, but you will have a very limited knowledge about your experimental space. You will only know what is required to reach your performances, but not know the why you have reached your target. And I think design of experiment can really complement this because you will focus on both aspects, the what and the why. So what to do in order to reach your target, and why did I reach my target based on the statistical analysis of the effects. So there are a lot of methodologies here right now on the market, and I think the data science community provides a lot of very interesting methodologies, but I don't see them as competitors or, they are more like complementary and alternative methodologies for DoE rather than competitors.
Yeah, I like that idea because, it kind of answers a part like also the next question on how do you see AI influencing design of experiments? We already like touched upon it a little bit, and that it also can make it already like more accessible. But do you see like other trends that might shape the future of design of experiments over the next years?
I think there is still a lot of research on, for example, optimal design, and we may not have reached the end of this story about optimal design. There are still a lot of opportunities to take in this area by generating a new optimality criteria and generating a design that are more suited for specific situations. I think also on the analysis part of design of experiments, we can now leverage a lot of different type of models. By, let's say, design, we were used before to create linear regression models in order to analyze the results. But now, with the different models in machine learning, we can use different types of models with their pros and their cons. And I think this machine learning modeling approach is very suited with specific type of design, like space filling design, because you don't assume any model beforehand. You are just trying to cover your experimental space in the most homogeneous way. And so I think this type of modeling approach, machine learning approach, is really well suited and well adapted to this distribution of points, because you can really easily interpolate with this kind of model what is the behavior of your factors with the points you have generated.
I think that that really like answers part like the question on challenges that are still there in the design of experiment space itself. And if we look now at more societal trends, like do you see a need for design of experiments there? I'm thinking like, for instance, climate change, removing chemicals. I don't know, like at L'Oreal, like how do you look at design of experiments indeed to make products more green or sustainable?
Yeah, I think design of experiment is a great approach when you have a compromise to do between different type of targets. Like you mentioned, we have different environmental indicators when we are creating our products. We also have the price that should not exceed a specific target. And for sure, we want also to reach the maximum performance on the different products. When you look at it, you know that you will have to do some compromise because not everything can be maximized. You will have some trade-off between the price and performances, for example, or some environmental indicators and the use of some raw materials. So design of experiments, because of this very a broad exploration of the experimental space, enables you to understand what are the trade-off, what are the compromise to do, and to guide your decision making in your project. Meaning, if you can allow to have a higher price because consumer expect higher performances, then you know with DoE on your experimental space in which direction you can go in order to increase the performances at a higher price. And on the opposite, if you want to have the maximum performances, but you should not exceed a specific price, then you also know what are the factors to leverage in order to reach this price and the maximum performances at this price. So it's really a key aspect in decision making to know what are the factors influencing the different responses and know in which direction you have to optimize these factors to reach the specific compromise and trade-off between all these responses.
And, we're developing like a new design of experiments software. And I wanted to just know, do you think that it's a good evolution that they're still also being innovated on the software side? And are these solutions keeping up fast enough with industry needs?
Yeah, I mean, having a new software in the market about DoE is always a good thing because DoE is not widely spread today. And anything that could help people doing DoE is a good thing, I think. So it's a good news. And people may also have a different type of expectation regarding user interface and user experience. So I don't think there is one software that could satisfy everyone. And so having different options that people could choose is also a good thing. I don't think DoE, looking also at the open source community and the different libraries available, it's quite hard to find a path and a good library that could cover all the different situations with DoE. So having having a software that can bring a lot of different tools to create a design is always a good thing.
And then maybe as a wrap up, if you could like improve or innovate like one thing in the way that design of experiments is applied today, what would it be?
Oh, tough question.
I assume, we're like, for instance, at FX, we know that, for instance, mixtures is like a very big issue in industry and a very tough one. So I was just wondering, like, are there like challenges that you say, like, if we can like to really like innovate on that part, that would really make my job a lot easier?
I think there may be difficult situation regarding two topics. When you deal with multidimensional spaces, but with very high dimensionality, meaning you have, 10 to 20 factors, and you want to learn the most from your experimental space, but with the minimum amount of experiments, I think this kind of situation can be quite difficult today, and even more when you had some constraint between different factors and so on. So I think this is not straightforward today to use a specific design on this type of use case. And as you mentioned, also mixture design are quite tricky, not necessarily on the design creation part, but more on the analysis part, because of this constraint that with the compound that sum up to a specific ratio, that means you have a specific type of regression modeling to do, and that you can't create a model based on statistical p-values or something, or very classical statistical indicators. So it's sometimes a bit tricky to create a model on this type of situation, and it can be quite difficult for beginners. I think the key part in a design of experiment, and that is not really promoted, let's say today, is the fact that you create a design with an assumed model in mind, but in fact, when you have collected your response, there might be different but equally performing models that answer your questions. And the key part is really to leverage all the statistical knowledge from statisticians and also the knowledge gathered by machine learning practitioners because they are used to do this kind of model comparison and selection. But the key part is really to be able to create different models, different competing models, being able to compare them, what are their pros and their cons, do the factors are the active factors in common between the different models, or do we have some discrepancy between the models, and if so, why? And at the end, perhaps not only select one model, perhaps is not perfect, but yeah, you can select one model, but you could also perhaps try to leverage the different models you have created and that could show similar performance, and try to average them and average the learning you can gather from them.
I was thinking like, yeah, I do also see that part where design of experiments, if I explain it to people, that I always, they kind of assume that with an experiment, you try to reach immediately the right solution, whilst, it's really about trying out different kind of formulations or something to see what happens within, so that you can see what you should not do as well. Yeah. So no, it's really cool.
And also, I think I didn't mention it, but when you compare analysis with machine learnings and analysis that you have done on design of experiment dataset, the fact that you have changed the factors in your experiments enables you to have causation instead of only doing correlation analysis, because machine learning models today are very often built on historical data. And so they can leverage correlation between the input and the output thanks to a model in order to learn from it. But design of experiment goes a step further, because as you are experimenting on your factors, then not only do you have a correlation between your inputs and outputs, but you know for sure that if you are going to change these factors to a specific value, then you can expect to have this change. And it's not only correlation, it's really you have done something on the system in order to reach this value.
Thank you so much, Victor, for your time and for answering all my questions. It was very interesting, and I've definitely learned a lot again as well. And I think the most beautiful thing that you stated was that design of experiments is all about learning and about also learning from your failure. And I think that's a very nice message that I would really like to take from this conversation. So thank you so much. So this concludes also our interviews.